Today, we are going to be talking about actually something pretty cool because we've already talked about inequalities and we've already talked about graphing two variable absolute values. So we're just kind of like moving it all together. And after this lesson, you should be able to graph the two variable absolute value inequality. You should also be able to understand that the graph of the absolute value inequality represents all of the solutions to the inequality. So that shaded region is going to represent all of the solutions to the inequality. Okay, so cool. That's great that we're going to need to know this, but let's just check this out. Here's some things we remember. If we have an equal sign on the bottom of our inequality, we include the boundary. If we don't have an equal sign, we do not include the boundary. And our graph will be shaded if there's an inequality, okay? So those are all of the things that are very similar to the linear inequalities, right? The differences, however, are that boundary is an absolute value graph, like a V, not a line. Linear inequalities are lines. Also, that instead of shading a half plane, we're either going to shade inside the graph, which is like right here, or we're going to shade outside the graph, which is like right here. So inside that V or outside that V, and that's the way I talk. It's not a technical term. Okay, cool. So let's check this out. We're going to use all of our same strategies that we've had before. So we know the parent graph, and I'm just going to reiterate our transformations without going crazy about it. So here's our parent graph. This one, okay, maybe before I start, you guys should pause it and try to do at least the graphs by yourself. Maybe not the inequality part, but you should be able to do the graphs by yourself. So that will be extra practice, okay? All right, so when we go to do this problem, we know that this guy is going to go to the right 2 and down 1. So we're going to go to the right 2 and down 1. And so our new vertex is going to be right here. And let's make this a little bit bigger. So our new vertex is there, and oops, I kept my to the right 2 down 1, and we're just going to go up 1 over 1, and then we're going to go back 1 up 1. Okay, so here's our new graph. Now we have to decide if it's solid or dotted. We look up here and we see the equal sign underneath, so we know that this is solid. So when we graph this, we are going to make a solid boundary. I know that I'm pretty slow. Sorry, guys. Okay. So I'm going to go ahead and erase the parent graph for right now. You can keep it there. It really doesn't matter. Just make sure you're shading in some other different color. Okay, so now what are our two options here? Our options for shading are the inside or the outside. So we have to decide where all the truths are, the points that will make the inequality true. Okay, how do we do this? Well, we pick one point that's not on our boundary. Now, we can see that 0, 0 is not on our boundary, but if we were kind of scared about that point because it's so close, you guys could actually pick another point like, I don't know, 2, 3 if you wanted to, okay? It doesn't really matter which one you pick. I'm going to pick 0, 0. So I go into my inequality and I put 0 in for y and 0 in for x, and I see if it's a true statement. Is 0 less than or equal to, oh, goodness, if you don't do the problem right, 2 minus 1. So is 0 less than or equal to 1? Oh, heck yeah, it is. Right? So 0 is less than 1, so that means that that is true. So what do you guys think? Are we keeping the blue or the yellow? Yep, you guessed it. We are keeping the blue because that's where all of the true answers were, okay? If we had picked that other point, we obviously would have had some false answers over there. But do we have to check it? No, we do not. Once you get one is true or false, you just pick the shaded region. Okay, cool. So just to review, we had an equal sign, so we made a solid boundary, and we also had to shade inside or outside. Okay, here we go. Next one. This one we are going to reflect the x-axis. We are going to go to the left 2, and we are going to go up 4, okay? So, wow, we got a lot to do. So let's remember what our parent graph looks like. I'm not going to draw it that big. The key is just really the vertex in this case. So we are going to take that vertex. We're going to take it to the left 2, 1, 2, and up 4. 1, 2, 3, 4. So our new vertex will be right here. It's also going to be reflected. So instead of going up, we're going to go down. So we're going to use that same slope, but instead of going up, we're going to go down. Now we look here and we see that this does not have an equal sign. So we are going to make a dotted boundary. And you should really keep going because that's what our graph is going to do. But I know sometimes it's a pain if you have such a big graph. But make it dotted and make it obvious. Okay, let's erase the parent graph for right now. You don't have to, I'm just doing it. Okay, so now what do we have? We have a blue shaded region. Now that's outside. And we have a yellow shaded region, which is inside. Okay, we have to decide which one has the true solutions. Okay, well, let's check. Is 0, 0 on our boundary? No, it is not. So we can try 0, 0 again. 0 is greater than the opposite of 0 plus 2 plus 4. So this is 0 is greater than negative 2 plus 4. So this is 2. Is 0 greater than 2? No, not a solution. Not true, right? Not true. So this is not true. So since our point is not true, are we going to pick the blue or the yellow to keep? Obviously the blue, right? So hopefully you said blue because that is the one we are going to keep, because if that red dot is false, then that means all the other guys are going to be true, the other space. Because the red dot is inside, we are shading outside. Okay, last one. And what's kind of cool about this is we are also, practicing graphing our absolute value function, right? So when we look at our parent graph again, it's right here. Our new graph, I'm going to try to use pink. So this is going to be compressed. And the whole thing is going to be moved down 3. So if we move the vertex down 3, 1, 2, 3, it's going to be here. Now, if we had compressed it, it would have been like going up 1 and over 2. You can see how this is the halfway point, right? Up 1 over 2. This is the halfway point, right? So all we're going to really do is move that vertex and then use that slope. Up 1 over 2. Up 1 over 2. Up 1 over 2. Now, we look up here. Are we going to use it solid or dotted? Yep. You said it. Dotted. See how much confidence I have in you? Okay. So up 1, back 2. And again, we are dotted. Whoa. All right, so again, you guys, I'm going to erase that parent graph, okay? It's just so that you can reference what we're doing. So we have to decide, are we going to be keeping the outside, or are all of our solutions on the inside? And like I said before, pick any point, but if you have the ability to pick 0, 0, do it because it's the easiest one. Is 0 less than half of the absolute value of 0 minus 3? So this says, is 0 less than negative 3? No. This is not a solution. So if the red is not a solution and it's in the yellow area, who are we going to keep? You said it. We're keeping that blue, okay? So now how weird is it that we actually kept all the blue? That wasn't on purpose. Also, something that I don't like is the fact that I just made blue on the other side. So I'm going to redo that. Just trying not to cross that, but give it more of a like oomph. Okay, I hope this helped you guys. Take care.